This is the pre-lab talk for experiment number 5 for Chem 110 lab, classes of reaction. The goals for this experiment are to become more familiar with the 5 classes of reaction that are frequently encountered in general chemistry lecture. In part 1 of this experiment, we'll carry out 16 test tube reactions and classify them and record observations from carrying them out. This involves thinking and understanding skill number 3. Recorded observations can lead to explanations, conclusions, or sometimes questions. We'll also use the solubility rules and the metal activity series to help write balanced equations for test tube reactions or to explain a result, whether it's a positive result or negative result. Finally, in the second part of this experiment, you'll be given the opportunity to design your own procedure to distinguish between sets of two unknown reagents in different sets. For today's safety pause, we note that there are several corrosive materials. Generally, many of the strong acids, strong bases, and copper sulfate solids are corrosive. We'll be using gloves for most of this experiment. We also note that ethanol is flammable and we want to keep it away from open flame. Finally, there'll be several reactions where we'll be producing gases or heating up a substance. For these reactions, we'll work in the air capture units. For waste disposal, we'll be collecting all waste for this experiment in a specially designated waste bottle. No reagents will be poured down the drain. And of course, we'll wear our PPE. We'll goggle it, and we're going to wear a flame-resistant lab coat. In lecture, you probably discussed various types of reactions that can occur in solution. You may have went over some basic general classifications of reaction. Let's go over 5 general classes of reaction here that you'll observe in today's experiment. The first type of reaction is a combination reaction, where you combine 2 elements or simple compounds to form a complicated molecule or compound. An example of a combination reaction is the reaction between hydrogen gas and oxygen gas to form liquid water. 2 elements combining to form a molecule. The second type of reaction is sort of the reverse. It's a decomposition reaction in which a complicated compound or molecule is broken apart back into elements or simpler compounds. The example given here is one that was used to figure out the law of conservation of mass. It is the decomposition of mercury 2 oxide solid to form liquid mercury and oxygen gas. The third type of reaction is a single displacement reaction. In a single displacement reaction, an element displaces another element from a compound. In our example here, magnesium solid displaces hydrogen gas from the acid, forming magnesium chloride and our hydrogen gas. The fourth type of reaction is a double displacement reaction. This reaction I like to call the ion swap. This is where compounds switch their cations and anions around. Many precipitation and acid-base reactions are considered to be double displacement. For example, given here, the reaction between silver nitrate and sodium chloride to yield silver chloride, which is insoluble in water, and sodium nitrate, which is soluble in water and will remain in solution. Finally, we have the combustion reaction. Combustion generally is a reaction between any fuel and oxygen that is in the presence of usually a spark or flame. In this experiment, we're limiting ourselves to the combustion of an organic fuel in the presence of oxygen to form carbon dioxide and water. The example given is the combustion of butane gas, which occurs when you use a lighter. All combustion reactions of organic fuels that contain carbon, hydrogen, and sometimes oxygen form carbon dioxide and water. As we carry out reactions in part 1, it's important to note the different types of evidence that we can look at that a chemical reaction occurred. If we don't observe any of this evidence, then we can conclude that the reaction did not occur. The first piece of evidence is a color change. Color changes are usually indicative of a chemical reaction occurring. The second type of evidence is looking for the formation of a precipitate, a solid that seemingly falls out of solution. The third piece of evidence is looking for a temperature change. You can fill the test tube in this case and see if it feels warm or cold. Usually the evolution of heat or the absorption of heat is good evidence that a reaction has occurred. The fourth piece of evidence is the presence of bubbling. Bubbling indicates that a gas is being formed and is usually good evidence that a chemical reaction is occurring. Finally, you might also note the formation of an odor. If you smell something, that usually means it's a gas. So this is also evidence of gas formation. We want to note here that to safely note an odor, we do this by wafting. That is, we wave our hand over the test tube towards our nose to get a small amount of the odor. However, you'll see in this experiment that is not even needed. The smell is going to be pretty evident for one of the reactions. Let's look at some procedural points for this experiment. One thing you'll note that there are lots of reagents that we've carefully planned out how to use. So some of the things that we did was make sure that we keep all of the reagents in our designated area. You'll note that on the lab bench, I labeled where each beaker and test tube goes so that I know what reagent is being used. In a face-to-face lab, usually the bottles are placed on the bench in the back of the lab. And it's very important that students put things back so that other students can find them. Another important thing you'll note is how do we obtain reagents. It's important to note that no matter what the reagent is, you never want to handle any reagents with your hands, even if you're wearing gloves. So, let's take a look at how we get reagents. For many of the metal samples, we can usually use the forceps in our lab drawers. In some cases, it might also be appropriate to just use a metal scrupula. If we need to obtain any solids and that need to be masked, for example, some of the reagents, there is an approximate mass to use. We made all of those measurements using a top loader balance. Remember, this is a more qualitative experiment. We're not very interested in exact amounts, just observing the chemistry. You'll also notice that when I set up the beakers for many of the reagents I used, I just poured a small amount in a 50 milliliter beaker and put it in a labeled area. Another thing you might note is that when I carried out the test tube reactions, I made sure to only use 1 to 2 milliliters of any solution. as I was saying, this is more of a qualitative experiment. We're not really interested in exact amounts, just using enough to observe the chemistry. You'll also notice that for many of the reactions where metals are needed, I only used 1 or 2 strips of the metal. This is important as well. For example, there'll be one reaction, I don't want to give it away, where it's a good thing I only used 2 turnings. Okay, I hope you guys have a lot of fun watching the video. I had a lot of fun making the video, so go forth and discover science.